Right, in this video we're going to review entities in solution. Yes, if you're in Chem 20, this is a new concept, and if it's Chem 30, we're looking at this in the redox unit. This is an essential skill for dealing with the redox unit in Chem 30, and we preview it in Chem 20. So this goes back to some Arrhenius theory. So Arrhenius was a guy who defined solutions and why their electrolytes conduct electricity, and what he described was electrolytes. And electrolytes are charged particles, so ions, that conduct electricity in solution. And so aqueous ionic compounds like sodium nitrate, we can determine if they're aqueous or not by using the table here. So nitrate is here, and most things with nitrate and most things with sodium are soluble because they're very soluble or aqueous. That's in Chem 20. We have a comparable table in Chem 30 where we find nitrates here and most things are soluble. So sodium nitrate is a highly soluble chemical, and it will break down into ions in solution. So if we have water dissolving sodium nitrate, we're going to have water is one of my entities. I'm going to have sodium ions that are aqueous as an entity, and nitrate ions that are an entity. Because the sodium nitrate is soluble, the water is able to pull those sodium ions away from the nitrate ions, because water is a polar molecule, and so the oxygen or the negative side is going to be able to surround the sodium ion, and the hydrogens, which are slightly positive, surround the nitrates. So aqueous ionic compounds separate into their ions. And since it's in water, that's a major entity. Solid ionic compounds like rubidium chlorate is listed here as having a low solubility or slightly soluble. Same thing in this table. Rubidium chlorate is slightly soluble. It's not that it doesn't dissolve at all, so it might conduct a little bit of electricity, but it is mostly going to remain undissolved. So you still have water present as an entity, and you have rubidium chlorate solid, and it'll be sitting at the bottom of the beaker if you were to dissolve this in a beaker, but most of the entities are not breaking into the ions, so maybe a few of them are there, so maybe it'll conduct electricity, but it's not going to conduct it well because there aren't many ions. It's a non-electrolytic for the most part. Now, strong acids, Arrhenius describes strong acids as particles that when they're put in water, so they're aqueous, then they will, most of them will break into hydrogen ions or ionize, and then you'll have nitrate ions. And so we have 6 strong acids that in Chem 30 are listed in your data booklet on the acid page, and these are our 6 strong acids here. In Chem 20, we'll usually tell you if they're strong, or maybe expect you to recognize that hydrochloric acid and nitric acid and sulfuric acid are strong acids. But they ionize, so they break into their ions. This will be a strongly electrolytic solution. It's going to conduct electricity. Water is present and the 2 ions. Weak acids will still conduct electricity, but most of them don't break into ions. So if I put hydrofluoric acid, which is a weak acid, in water, most of the hydrofluoric acids will remain as hydrogen fluorides. Less than 50% of them are going to produce hydrogen ions and fluoride ions. Discuss that more in the equilibrium unit in Chem 30. Aqueous molecular chemicals like methanol, usually these are going to be smaller, very polar molecules that have hydrogen bonding. But methanol is not going to break into ions, it's a molecule. They're very soluble, so it'll be aqueous, but those are the 2 entities that are actually in solution. That's what's floating around. Insoluble molecular compounds, something like maybe propane gas, it's just going to remain as, it's going to remain as propane gas, and it's going to bubble out. Like it's not going to stick around in solution in any great concentration. You might have a little bit of it left there. You may have seen pictures or videos of methane gas in water wells that are combustible. But elements, we generally would say they remain in their own state, and most of them are not listed as aqueous. So if we have oxygen gas, a little bit of it will dissolve in water, but most of the oxygen gas just bubbles out. So you need to be able to identify what the entities are in solution. Aqueous ionic compounds break into ions. Strong acids break into their acid particles, so they ionize. The solid ionic compounds have a low solubility, so they're mostly just going to be the solid in water. The acids will all be totally soluble, but weak acids are not going to mostly ionize. Molecular compounds that are soluble will be aqueous. Not low solubility, nonpolar molecular compounds will remain in their state, and elements are going to be in their state. So you need to be able to do that in order to be able to get net ionic equations, as well as be able to do the redox unit.